All right. So in the last video, we looked at absolute and relative extrema, and we actually cut it off a bit short before talking about critical points. So let's talk about critical points in this video. So what is a critical point? Well, a critical point is essentially just a point that could possibly be an extrema, a max or a min. So a point that could, again, it's not definitive. If you have a critical point, it doesn't mean that it is for sure an extrema, right, a max or a min, but it has the possibility, so it could be an extrema, could be an extrema, right? So what that means, it could be a max or a min. So that's what a critical point is. So how do we identify if we have a critical point, right? So effectively, if we're looking at a graph, right? Let's say we're looking at a graph like this, where we have, I don't know, some curves going something like this. Sorry. Right, if we're looking at something that looks something like that. So we know that this could be a critical point. This is a critical point. This. These are all critical points, right? These are all things that, so if you have something that is an extrema, it's going to be a critical point. But not all critical points are extrema. But basically, what is something that we can say about this? Well, or about each of these critical points, right? Well, firstly, if we're looking at each of these, let's look at the first one here. We can say that the derivative of this point, derivative of the critical point, right, is 0. The f prime, if this function is f prime is going to be 0, right? We know that the tangent line is a horizontal tangent line here. So we would have a horizontal tangent line, which means that the slope is 0 here. So the f of f prime is 0. Same thing over here. This also would have a horizontal tangent line. So f prime is 0. Over here, f prime is 0. This is also f prime is 0. Same thing over here, f prime is 0. You'll notice that I didn't do that over here. So we have something that actually forms a corner. So this is a critical point. This is a critical point. This is a relative maximum here. But the reason why this is not f prime is 0 is, if you remember, if we have something like this, we have a corner there, the derivative does not exist, right? Or the slope does not exist. So it's important to keep this in mind when we're now looking back at how do we define a critical point, because, well, one, if we see that our slope, the f prime of x, does not exist, right? If the f prime of x does not exist, we're looking at a critical point. Or two, if our f prime of x is equal to 0, then this is also a critical point. So if we see that the slope does not exist, that means, again, we have a corner. That's a critical point. It has the possibility of being an extrema. Or if we have the slope equal to 0, or f prime of x is 0, then that's a critical point. And again, that has the possibility of being a max or a min. So in future videos, we'll go into more detail of how we can, if we find a critical point, to determine if it is a maximum or a minimum. But in this video, all we'll look at is how to identify, right, what our critical points are going to be. So hopefully this makes sense as to what exactly a critical point is. So now let's look at some problems and try to actually identify them. Hopefully from what we've said so far, you can kind of already get an idea of what problems we would look at and how we may approach them, but let's go into some more detail. All right, so looking at some basic functions, let's try to identify the critical points. So let's say we have a function f of x, or function f of x, which is equal to x squared minus 4x squared minus 4x plus 3. So we have this function here. How do we find the critical points? Well, we know there's two criteria, right? Well, one, we need to see if our f prime of x does not exist. We know we have a critical point. Or two, if our f prime of x is equal to 0, then we know we have a critical point. So let's start by taking the derivative and setting it equal to 0 to try to see if there are points when, our f prime of x is equal to 0, right? So f prime of x, what is the derivative of this function? The derivative of x squared minus 4x plus 3 is 2x minus 4. So this is our derivative. So now we have to set this equal to 0 in order to identify our critical points. Doing so gives us 2x equals 4, x equals 2. So we can see that we have a critical point at x equals 2. Simple enough, right? So again, remember, this doesn't mean that we have a maximum or a minimum at x equals 2. It just means it possibly could be some sort of extrema. All right, let's look at another simple example. So let's say we have a function f of x, that is equal to x cubed minus 3x squared plus 2. How do we do this? Feel free to pause the video and give this a try. So we'll approach this the exact same way we did the last problem, right? First, we need to find the derivative of this function. Then we can set it equal to 0. So our f prime of x is going to be 3x squared minus 6x in this case. And so we want to set this equal to 0. But what you'll notice is we can actually factor this out to write it in a more factored out form, which may be a bit simpler. So we can rewrite this as 3x. You can see that you can factor out the 3x. We get x minus 2. So 3x times x minus 2. And the reason I just write it this way is that it may make it a bit easier to identify that there are actually more than one critical point, hint, which is a bit of a hint. So how can we make this equal 0, right? This would be equal to 0, 1, if the component in the parentheses ends up equaling 0, or if the outer component equals 0, right? Those are two ways that we can make this function, or this expression equal 0. So how would the component, this x minus 2, equal 0, right? Well, if x is equal to 2, 2 minus 2 is 0, and that would give us an answer of 0. So our critical points here are 1 is when x equals 2. Now there's another one, right? How can we make this outer component equal 0? Well, if x is equal to 0, 3 times 0 is 0, and that would distribute over here, so the entire expression would equal 0. So we have another critical point at x equals 0. So these are our two critical points here. Again, these don't, does not tell us definitively that we have some sort of extrema here, but it just indicates there's a possibility that at x equals 2 and at x equals 0, or at x equals 0, we have some sort of extrema. All right, so this is really all you have to do in order to find a critical point. It's very simple. Again, we just take our function, we take its derivative, set it equal to 0, make sure, again, in this case, that there were more than one critical point that we could derive from our expression. So make sure you are evaluating this correctly in order to identify all possible critical points. And in future videos, we'll be able to see how we can identify whether a critical point is a minimum or a maximum, and many other things from this. But that brings us to the end of this video. If you found it useful, please show your support by liking and subscribing, and leave in the comments any questions that you may have. And I'll see you in the next one.